Thank you very much for attending this a workshop for apps and video consoles. We are going to start with one presentation by Mrs. Helena Rojas Balduciel. She is a consultant on usability e-learning in Venezuela. She has got a PhD in this field, and she is a specialist in virtual learning environments. She holds a bachelor's degree in computing in Venezuela. We can create apps, she says, in a very easy and accessible manner with a screen reader. The question, or the answer to the question, is going to be given by her Helena Rojas. Good afternoon, ladies and gentlemen. First and foremost, I'd like to thank the scientific committee of the ENG Foundation for giving me the opportunity to address this audience and present my paper. Among the reasons that led me to embark on this journey is a user. Those who know me will know that I've been fully blind for the past 10 years. And for us, accessible apps are paramount. After a brief introduction, I will talk about the motivations to this work. We will also talk about apps themselves for Android mobile phones, Android systems. We will talk about the resources that we use, the app builders that are commonly used for the creation of these type of apps. We will talk about which type of apps can be created with the app builders. We will briefly display the methodology developed in order to easily pick the apps that we are going to test, because this is indeed a test, an experiment, trying or attempting to see that whether we are going to be able to create this type of applications with a screen reader. So that is the goal. Can we really create mobile apps by using the app builders, which are online tools? The work, we all know that there's been rapid improvement in the creation of mobile devices and tactile devices and screen touch devices, and we are spoiled for choice. We have iOS, Android operating systems, and any given user, including impaired people, we are also part of the market. It is important for these apps to include support and assistance for people with impairment, including visually impaired users who extensively use these devices. My motivation was as follows. By reading many mails and mailing, I realized that this was an ongoing concern among the visually impaired. People asking, can I do this with Google Play, for example? I read this all over the place, and that motivated me to embark on this journey. If you ask me what I used, well, my available resources, a Windows computer. And in order to test the functioning and accessibility of use, I tried with Google Chrome, Mozilla Firefox, and Internet Explorer, 3 different browsers. I used JAWS, the 13th version, and NVDA. What are the apps builders? It's very simple. These are online tools allowing you to create applications. They are user-friendly, and they are developed so that any given user with no programming knowledge whatsoever can do it themselves. It's based on the DIY concept. And the learning curve is very short because it really works very well. What type of apps can we create with this type of app builders? 3 types mainly. Native apps, those running through the system by using the system's users. Hybrid apps, using resources of the system which are embedded on it. The interface that the user is using, it's a web interface. And the web apps. Those are more commonly used. The apps that allow you to access one website through your mobile device. What are the most commonly used for the development of the Android system? As my research shows, I found the top 5. iBuildUp.com, Andromo.com, appbayet.com, freeandroidmapmaker.com, and appscazer.com. With these different apps, well, I have created a chart with the main features. Most of them are free, excepting Andromo.com and iBuildUp.com, which allow you to run a demo app, but then you have to subscribe if you want to continue creating further apps. We had 5. It was difficult to try them all, so we selected 2 of them and analyzed which one of those provided a more accessible use. We developed a simplified methodology based on the accessibility assessment methodology, web accessibility assessment, so the automatic stage A and B, the manual stage. The automatic stage includes examinator because it's user-friendly, and the ranking that it provides is a quantitative ranking which gives you an overall idea of how accessible this app is. On the other hand, in terms of the manual accessibility, I built up an Excel spreadsheet, and I followed the WCAG 2.0 guidelines, and I set up a list of criteria, and I was measuring them against 3 different sets of criteria in order to obtain a quantitative outcome. The most accessible were Andromo.com and freeappmaker.com. 7.2 for Andromo, and the other one obtained 60%, and the other one obtained different results, 6.7 for examinator and 64.7 in the manual evaluation. We had to choose the easiest and most common or user-friendly. There is vast amounts of information on the internet. Users are using the social networks, and people with impairments create their own blogs because they want to, and we wanted to allow them to share these contents with one app. We created a feed reader. In general terms, this is commonly used. I mean, smartphones and smart devices are extensively used. What were the results with the creation of the feed reader? Andromo.com follows a complex process. It requires registration, one initial query. However, it is pretty accessible there are no major barriers or accessibility problems. In other browsers, for example, Google Chrome, it looks like they do not like the screen readers. Well, we had a problem. The behavior was rather strange. However, the information is requested easily. You just have to submit your email address, and they will submit a confirmation email with a link in order to verify the account. Once you click on the verification of the account, you just can see the application. Everything is done over the internet because this is a web application, and then you can start creating your own application. It is rather easy if you're slightly experienced, because they present a multiple tab interface. For naive users, this type of display might lead to confusion. However, as I said, there is a very short learning curve. You can create activities, numerous pages that can be accessible for users, and perhaps you can read the feed and Twitter as well. Once the forms are filled in, because everything is done through different forms. However, there are different hindrances. It presents icons with alternative text that is not very intuitive. It isn't easy to understand the icons because they present non-standard icons. However, they provide you with the possibility to include your own customized icons. If you are someone with impairments, you can customize the icons, and the only thing left to do is to see how are you going to spread it. Is it with Google Play, or can this be downloaded immediately with a link that can be submitted through email or through your desktop? What is the main difference with free Androidmaker.com? This one is easier because you do not need to register beforehand. You only have 3 steps, and the home page, when you say I want to develop this or that app, has 2 links with different wordings, and it is not intuitive at all. And once we discovered the entry access, you use the feeds reader, the first form, and you introduce the information of this blog, and they will automatically provide the information of the blog you have created. On the next screen, you have a config form allowing you to customize it and configure it. However, the problem with this form is that the buttons and the controls, the radio controls, can supposedly allow you to select the icon. However, the problem with the icons is that they are not intuitive at all. However, you can use it with a screen reader. You can create different apps without the need to pre-populate one initial form. You just click on a box and download it automatically, or you will just automatically upload it to your Google Play. Now, by way of conclusion, I'd like to say that in general terms, they have certain problems because they do not present an alternative text or wording. However, these might be solved. It's not like in other cases where they don't even have an alternative text. It can be used with the keyboard. Certain screens have complete access, and Andromo.com, if you're using JAWS with Internet Explorer, allows you to do so. And it is fairly understandable because Andromo.com provides extensive documentation to avoid mistakes. There is tons of information, although it's only in English, but you can learn quite rapidly, as opposed to freeandroidmaker.com, whose information is quite complicated, but the tool is user-friendly. In conclusion, can we create apps? Yes, of course. With these two tools, quite easily. Now, what are the obstacles we need to overcome, or they need to overcome? The study needs to take place again, because it was done with Windows, and now we'll have to do it with Linux and Macintosh, because some others do not use Windows. And it is interesting to see the behavior of these tools with other platforms and other readers. And we also have to include people with other types of impairments, and to see to what extent they comply with the universal design principles. But most importantly, we have to see whatever happens with applications that are created with this type of development tools. Are these applications accessible? Are these contents accessible? Because both for Android and Apple, we find ourselves with numerous non-accessible applications. And last but not least, it is important to see whether, if they comply with the WCAG 2.0 and the ATAG 2.0. I hope you found this information valuable. My final aim is to provide the users with all the necessary resources. We need to give them the necessary technological tools so that they can work and live in equal opportunities and benefit from technology as it should be. Thank you very much indeed.
Muchas gracias. La fase de preguntas se hará al final.
¿Cómo no?
Entonces,
me voy, ya voy.
La fase de preguntas se hará al final.
Perhaps we can leave the Q&A session for the very last part.
Sí, estas, ¿no?
No, este es el vídeo.
Es
Plantea este. Vale.
Bien, pasamos ahora a la...
Jaime Oscar Casas is our next keynote speaker, along with the co-author David Conde. The paper is entitled Integrams, Accessible Control of Video Games for Xbox 360, PS3 and Wii, and also PC. He is a professor in the Telecom University in Catalonia. He is a telecom engineer, and he has a PhD by the Politecnica University of Catalonia, and he is the chair of electronic engineering in the UPC University, and he lectures numerous courses in this field. His research includes the design of new interfaces of autonomous sensors, physiological measurements, non-invasive ones, and impedance, electric impedance, and the development of new domotic systems, as well as alternative systems for people with impairments. In 15 minutes, he's going to explain what they've done. That's a lot of pressure indeed, eh? Just giving me 15 minutes to. We'll do it as the best I can. Just 15 minutes you have. Yes, we have to try and stick to the original agenda, especially after lunch. Good afternoon, everybody. Over my presentation, we'd like to present the result and the outcome of a project. The product should be marketable, should be reaching audiences. Not to give a solution to the first needs, but to just give a solution to the leisure. Leisure nowadays is present in everybody. We want to have a leisure time. When you talk about people with impairments, you say, or they argue, yes, of course, we'll have to solve the primary issues, primary needs. Of course, I agree with that. And in this conference, we see the solution to these primary needs. But we shall never forget that they shall live in equal conditions and they shall enjoy leisure platforms such as the Xbox, PlayStation, Wii, and PC. People with impairments should be able to play any game in any platform. It is a very ambitious challenge. The idea came from the third part of the puzzle, one user. The user is David Conde, someone with an impairment, and he addressed DZ, and he said, I want to play with a PlayStation, and I know, or I'd like to know that I can win sometime, that if I practice, I'll win. Now I am playing with my friends, but I can't do anything because of the difficulties of the games and the joystick. It's not really user-friendly for us. David Conde mentioned it, and I could argue the same when I see my kids playing and what they do with the hands. I find it really impossible. So, given this premise, giving an interface to these people to play with these video consoles. When we talk about video games, they are increasingly, and you will see this in the second room, the use of Wii in rehabilitation, cognitive restoration, and we've seen that the use of certain games for these type of diseases and limitations. It's about playing Mario Kart, any given game, and the capacity to play in under equal conditions. It is mainly for people with motor impairments or intellectual impairments. What do we have so far? If you take a look at the market, great steps have been undertaken. Okay, I simplify the games. I will design one game specifically for people with impairments. But there are two limitations. A, most of these people, they just want to play exactly the same game. They just want to play the same game with their pals. Second, the cost. Unfortunately, we have a cost problem. Developing a specifically designed game for people with impairments is very costly. The solution would be perhaps to talk to Mr. Wii. Please, why don't you just launch one game for people with impairments? We know the answer. We know it entails a cost. So this is perhaps a non-sustainable solution. Another element is the hardware design of specific peripherals. So instead of using the joystick, perhaps they can use different peripherals. And this is something that can solve part of the problem, because the person can use this peripheral. But two questions. Why can't they use the joystick that they are commonly using, for example, the wheelchair's joystick? And the second difficulty, the current joysticks in the video console have like tons of buttons, and it is very difficult for them. And that makes things very difficult. There should be a translation between those two physical elements. As I said, we've got the Wii, the Kinect from Xbox. These are platforms that have introduced a novelty interface with a win-win success. If you move your arm, it's wonderful. Everybody likes these type of solutions, and this cartoon reflects that it's a solution, but not for everybody. So we don't want to say, okay, this is the solution. A solution for everybody is impossible. We just want to cover a niche for certain individuals who cannot use these joysticks or platforms, and who do not find a platform where they can play. And the idea and the goal is very clear: reducing the amount of buttons, and I'd like that for myself too, for the record, and to make certain sequences automatically. You can't press all these buttons at once. I mean, there must be a software allowing the person to just press a button and to do those 4 actions at the same time. And on the other hand, the control of the game pads from any part of the body. That was a challenge, that was a goal. And the goal needs to comprise hardware and software. It has to be holistic. To develop a software that can be fully adapted, which requires programming for everybody, that is customization. And on the other hand, a hardware that can optimize the use of the software. Everything's been developed to reach the biggest amount of people as possible, which entails a hefty cost. We need to opt for the cheapest solution. The ICTs allow us to do the following. As we listened earlier on this morning, the hardware a year ago was very cheap. If you were given mobile phones for free. So the goal was to get a cheap hardware that can be easily adapted, and to do a software that can be adapted to it. I won't go into detail in terms of the hardware, although I'd love to, but we do not have much time. We are talking about 3 blocks. The entry interface is the USB stick, the flash drive, any given adapted keyboard, any adapted mouse, and any entry. And this allows you for complete freedom. Why 4 entries? Because then we can play with numerous users, with 3 other users, for example. If Mario is in the car, that can be controlled by 2 people. Someone can control the speed and the other one can control the twists. So this introduces the cooperative element, or different parts of the body. It it is very flexible. The second block, it is the intelligence, a low-cost processor like the one introduced in and embedded in mobile phones. And finally, the exit, one element which can adapt this to all the consoles communications protocols. They have to translate all this into different rules. It has to be as generic as possible. Two elements have been introduced. The browsing joystick with a single element, one single button to choose the option. It's slow, but it can be partly offset. We have created up to 8 different entries, and we have tested everything, and I'll display a video afterwards regarding customization. The core has to be as cheap as possible. Mobile phones, microprocessors, for example, and we picked up the chip from one company, which is the supplier to Samsung, and we took the CPU at 700 megahertz, which is enough, more than sufficient, with one operating system to work on real-time Linux. And from that moment onwards, we implement a system that allows us to do absolutely everything. It's only about reducing cost. This is just another solution, controlling one PC with another PC.
Absurdo. Pero
To translate between PCs, but if I want to have something as similar as possible with a minimum cost and a minimum size, because this is the size of a credit card, we can move forward with the solution. A card like this costs about 30 euros if you buy them separately. So from the cost perspective, it is just perfect. This was the important part with this processing, because we need to manage the user interface. As it says, it needs to read the actions carried out by the joysticks. So it needs to manage any type of joystick, and also it must upload the macros, and that will depend on the game and on the user. And these macros can adapt in time. If in the beginning it's too effortful, you can simplify. They're already telling me that I need to go faster, sorry. Well, if possible, it can also be sped up. So the macro is very important. What have we done from the macro point of view? We have translated everything: hats, buttons, access, a keyboard, a mouse, and we have created a language of our own so that you can carry out actions every 16 milliseconds. Every 16 milliseconds, you can send an order, a command, so they can record these macros. So you can push a button, and pushing a button could send commands that would last up to 60 seconds. It could take any time, and you can put together 4 buttons, and it can be direct or bidirectional. And also it needs to be adapted. And what do? We tested it. Please, first of all, in the lab. Here I have David Conde, who's been working on this actively. I'm here at the forefront, but he's the one that has put more work into this. So he got people who didn't know how to game, and for example, me, and other people who just walked by the lab. He engaged them with this gaming. He had a simulator, an Xbox, a PlayStation, so on a daily basis he just came and played. And since he was playing, colleagues and people who just walked by wanted to try the games. And specifically, we are going to show you an example in Mario Kart. What we did was to adapt the typical remote to the DJ card. So we ran some tests. We are not going to enter into this because it's very descriptive. It looks good enough. There's a person who describes it here in the video. But how did we do this? We got Joaquin to run this test, and Joaquin is going to tell you about the results, and you can watch the video and see the results for yourselves. The best would have been to be able to play here in the room, but for the sake of time, we are going to watch the video. It'll just be a little second. I'll be brief. The best to understand how the system works is to see it running. In this case, what we did was to adapt Wii's Mario Kart to Joaquin's joystick, because he has MS and he has reduced mobility in his hands. He already uses this joystick to move his wheelchair or his control chair. So he, on a daily basis, he uses this joystick, and he's very skillful in using it. So the matter was to implement a USB port, and through our system we managed to get him control the steering wheel of the vehicle. As we can see here, in some cases the game was too fast for him. In here you don't see me, but I'm standing behind and I'm using the cooperative game by controlling the acceleration of the vehicle. And if I see that the vehicle is going very fast, I push the brakes, and Joaquin is the one who is driving left and right. He didn't finish last, and for being the first time that he was playing this game, he managed to rank 6. We adapted all macros and everything that has to do with the enter system to his joystick, but this can be done in an individual basis for each person. So to a certain extent, let me close the video now. For the sake of finishing the presentation, I'll say that what we've done is to simplify a system as much as possible so it can reach everyone, every single individual, and every type of gaming device and game. So this is set by users. We've used hardware and users in order to carry out this project, and it enables us to do something new, which is not to pay on in an individual basis, but also in a collaborative basis. People with disabilities could compete with one another. One person could use the same game device to interact. So it enables us to interact between people with disabilities and without disabilities. So there's a high level of interaction. And just to finish, I would like to say that the cost is minimum. So this is what we wanted to present as fast as possible. And last but not least, I would like to encourage you to go by Barcelona, by our campus in Castelldefels. It's in the outskirts near the Olympic Stadium. So if you ever go by, please visit us at the telecommunications building, and at least you will be invited to play with us some games. Thank you very much.
Vuestro es este, ¿no? No sé, el nombre de... Antonio Bermúdez, y luego, ¿el otro quién es? Dime el nombre. Ah, es que estáis ahí. No lo había visto. Gracias. Bien, vamos a pasar.
We are going to start with the last talk for this session. It is entitled Audio Description in Mobile Devices. It has been prepared by Antonio Bermúdez Casbra, who is a software engineer in the Research and Development Department of the Research and Development Center on Tiflotechnic Application in ONCE. He graduated in the University of Granada. He's got a long-standing experiences in software development. He knows about accessibility and Tiflotechnics. He's participated in research programs regarding neural networks and neural algorithms. He's participated in the conferences such as Artificial Life in the Institute of New Mexico in the United States. He held several positions in IT departments and research and development in companies that have to do with the audiovisual sector. Currently at ENG, he has participated in projects that have to do with accessibility, such as Son of Riley, which is a noter with voice synthesis facilities and Braille. Also, he's worked on projects that have to do with GPS. U-Type integrates Braille and can be connected to mobiles, computers, and PDAs through Bluetooth or infrared technologies. Ismael Selma Cordero is the founder of the technology companies S2. He was director, manager, and a key stakeholder in Iberus. He is a engineer, graduated in the University of Seville, and he's got an MBA in ICT. He's participated in multiple projects for different industries, financial administration and companies. He's undertaken all sorts of tasks that have to do with the market cycles and development of ICT projects. He deals with implementation of information approaches. He develops technological solutions for mobile webs, and he deals also with banking platforms for the financial industry and for different public entities. He currently belongs to the INES board, and he's part of the technical committee that assesses the compliance promoted by the Board of Health of Andalusia. You have the floor. Good afternoon, everyone. I will try to introduce you to the Odesk mobile project. It tries to provide audio description in mobile devices for the visually impaired. Is promoted by the ONCE and the Vodafone Foundation Spain, and also undertaken by the company S2. I would like to tell you about audio description and what it is, although we're more or less familiar with it. It's basically about having additional information on an audio basis that enables visually impaired people to get to know what is going on in what they're seeing. For instance, all the additional information that the subject is not perceiving would be sent to him or her through this sound file. They will tell him or her about gestures, dresses, outfits, any element that's relevant to correctly get to know the plot of the movie is something that we will tell him through audio description. These descriptions are inserted in between dialogues, and this enables the visually impaired person to follow the movie without any difficulty. Audio description has existed for many years. Already in the year 1975, Gregory Freitzer wrote his thesis on this topic, and he used as reference his daily experience. He saw that blind people went to the movies with people who knew them, and these people described to them what was going on in the movie. So this is included in the description. Apart from radio broadcast, we are all very familiar with this theater representations. Apart from actors, there were narrators that told us what kind of things happened in order to follow the plot adequately. I am telling you all these things just for you to see that this is nothing new, that it's been long-standing, and nevertheless it needs to be more broadly implemented. The current situation is that in not many movie theaters they have an implemented solution. They have radio frequency devices, and but this involves a very high cost of installation, and also it is quite complex because you need to set up the movie projector. Also, from the user point of view, it forces the user to have an additional device, a pair of headsets that he will use, and through that channel they will receive the audio description. All this situation makes the description not to be all that extended. It seems reasonable because there are not many movie theaters where you can go to watch a movie which is audio described, and because of that reason they don't have many customers, and this is why production companies are not so interested in such a small market. All those problems are the ones that we try to sort out through projects like this. That would be the first goal. So the objective that covers everything that we do is trying to solve this type of problem. So we want to replace those additional devices by daily life devices, for instance, mobile phones. It's about having a simple and cost-effective device that's in everyone's reach. Audio description is a need for this group of people. It shouldn't entail an extra cost or an extra complexity. That will be the ideal situation. Also, another goal that we have is for the visually impaired to be completely self-dependent when accessing audio description. Since the very first moment, the user can make a search for a movie for the audio description, upload it in his or her mobile phone, and play it without needing a third person or an extra device to enable him or her to access. And also another objective that we have set for ourselves is to have this platform as something completely independent. Only certain movie theaters offer this service right now, so it shouldn't depend on whether the movie theater is adapted or not, or even depend on going to the cinema or not. We can take audio description to other platforms. Perhaps we can watch movies in our home or play a DVD and have this audio description available. So in short, if we manage to fulfill all these objectives, what we would be achieving is to enable availability of audio description in many places, not just in premises where it is already implemented. But I could go to my neighborhood's movie theater and have access to audio description through my device. And not just in the movies, I could receive also audio description if I'm watching TV or playing a DVD at my own home. So audio description would also be more attractive for production companies. There are many users who want to have available audio descriptions, but wanting to go to the cinema and having the technology does not have all that many users. So in doing so, we would make this product more interesting and thus encourage a larger market. And now give the floor to Rafael, who's going to tell you about the more technical details regarding this topic. Hello, good afternoon. I think that Antonio's explanation clarified the objective of our project, and I'm going to delve deeper into how the system works. Tomorrow we will have a workshop, and there we will display a full demo in which we start playing a movie until the point when the mobile phone starts describing the audio content. The goal for this project is taking all these things closer to devices that everyone has, which are mobile phones, and also having the possibility to receive audio description at any point in time will be adequately synchronized with whatever is being played at that moment. So there's a server side that stores all audiovisual contents. Also, there's a web environment. In this case, it's ONCE, where they are uploading all their contents. There's a library that covers over 20 years. Now they are uploading contents that can be accessible for all sorts of users. And finally, we will also have a mobile application that can be downloaded by users to use the content. So this is the graph. We have a server where we have the contents. We can download the contents which are typified in terms of categories, as movies, series, documentaries. We have the advantage of being able to watch it anywhere we want. And then finally we have the mobile application. When we tackled this project and it became a reality, we came across two challenges. How do you manage an audio file that's very large? How do you do it so that you can manage it in a mobile device? Memory constraints are important to store that amount of information, and also data speed was also very important. So I need to have a file that clearly identifies the movie that I'm playing, and also at the same time it must enable me to send information to the smartphone so that they can synchronize, the smartphone can synchronize the information that it's receiving. So we needed a file. It's an acoustic audio footprint. This was converted into a format that we have developed ourselves. It enables you to compress it at such a speed that it's very easy to index and search for information within that file. We're talking about a conversion that goes that is about reducing 400 megas to 30 megas. In order to manage this algorithm, people from physics and mathematics areas have dealt with this algorithm. It's a spectrum that we have applied this algorithm to obtain the frequencies to eliminate noise or silence, so that we can compress as much as possible all this the file. So when we started working on this file 2 years ago, we all knew Shazam. You possibly know it. When a music's playing, the program tells me what song that is. In principle, we wanted to use that algorithm, but it had some downsides to it, because specifically you needed to track that in a specific moment of the movie and then put it in our mobile. So this is why we developed these algorithms that I was trying to tell you about. Even though I have some limited time, I would like to tell you some points regarding this. This represents the second drawback, which is synchronization. How does the system work? The system is very simple. I download the app to my mobile device. The mobile device records for 5 seconds the audio file that's being played at that moment. It may be a dialogue, it might be a soundtrack, it might be steps. We take that sound, we package it, we send it to our server. We create that acoustic digital footprint in that format that I mentioned earlier, so I can track the specific moment of the movie where I'm at. And at that moment, I'd send back to the mobile phone the exact moment that the movie is at, so that I can continue the synchronization throughout the whole movie. Once we got rid of this hurdle, we realized that there was a lot of delay. We tested this and with a series of mobile phones, and we realized that you had to take into account the microphone speed even. It doesn't, I don't know, an iPhone 5 doesn't have the same microphone as an Android-based mobile device, and it's not the same to be at the movies than to be at home. So after carrying out many tests, we managed to implement an algorithm that takes into account all these things. The reproduction, the speed rate, and the device rate. After a time lapse, the system referred back to the server and tried to resynchronize. So now we have all the different parameters: the speed for the movie, the speed of the microphone, the digital footprint, and all sorts of things. And I really encourage you to come to the demo tomorrow, because this system is very striking. So this is the result now. Technically, we thought that we had solved everything that had to do with the algorithm, and at that moment we were capable of sending the information regarding the point in time at which the movie was to the mobile device, and we realized that it ran smoothly technically, but we hadn't had taken into account the collective that we had put this together for. This application should have been adapted for this group of people, and obviously Fundación Vodafone and ONCE Foundation were the best partners that we could find to help us determine what the graphic interface should be in order for this program to be used and accessible for any people with visual impairments. On this task was very important along this in this line of work, but also in the testing part. Testing this in a room like this, for instance, with users was a challenge, and also we also tested this in a movie theater. We got a set of users who were visually impaired in the movie theater. We played a movie, and this is how we tested it. You can see that there's a lot of personal and professional satisfaction in doing projects like this, because you can witness how technology helps people live in a more accessible way and in a more accessible world. So we have implemented the different features. At this point, we are revisiting the application to make checks. Whenever there are new contents, the user is told that the content is available. We are now implementing many other features. But the final conclusion that I wanted to make, and as Antonio said also, we have managed to achieve something very important, which is that any user with their smartphones can access all audiovisual culture, and they can access all these culture irrespective of on what place you're watching this audiovisual file, at the movie theater, at your home, at a friend's house, or wherever. So we are trying to cover for all the deficiencies. The movie theaters no longer have to make a special investment to adapt their theaters, or the production companies have to make an investment. This is something that we no longer have to face. This is a natural environment, and we are harnessing the available devices that we all have, thus broadcasting visual culture. Thank you very much.
Vamos a invitar a los ponentes.
We are inviting the different speakers to come close to the table so that they can answer the questions which are going to be posed. We know that we're lagging behind a little bit, but we'll have a Q&A round nevertheless. We will have a question and answer round anyway. I think there's a question at the back of the room. Good afternoon. My question is for Elena. I would like to know if there are any apps that you're acquainted with that have been created with those app builders that you mentioned, and that can be downloaded, so that we can know the use that has been given to this type of tools. Honestly, not that I know directly. But I imagine that if you make a search, you will possibly be able to identify some, because through the free app maker, you can find out if they were created using this tool with the free Android maker. That's something that my work did not cover, but I imagine that you could do that. You can verify them and identify them. You would have to download them and to test them on a mobile device or a simulator, but I imagine that there are some, but not that I can mention apart from the one that I created, of course. There's another question over here. Yes, hello. Good afternoon. I wanted to ask those two speakers that were talking about audio description the following. Well, I wanted to ask a question and a reflection. The question is, according to what you explained, it is my understanding that when the equipment detects the movie that's being played, be it at the theater, be it at home, what it does is to send to the mobile device the audio description and the audio file, or only the audio description, because if you're hearing the audio from that room, but also the mobile device is giving you the audio file with the audio description, it is my understanding that there shouldn't be any synchronization problems, because you can reproduce, you can play the movie at your own pace in the equipment. But if the case is that it sends the audio description, it should synchronize with the audio provided by the location where you're at. So I didn't understand that very well. And I also wanted to make a reflection, as I said earlier. I think this is a fantastic idea, and I need to congratulate you for this initiative because it's a great step forward. But I do think that we need to be careful when you try to present this as a big solution for audio description, especially with everything that has to do with movie theaters. Because this places the economic cost in the user size and also the responsibility for coming up with a solution. Of course, movie theaters will no longer have to make any investment. Nevertheless, I will need to have a smartphone or an Android phone or a top-level mobile device that I purchased myself in order to access this technology, and of course I will have to purchase this application. I imagine it has a cost too, because it must have it. You've done a lot of effort in developing it, so I imagine this has a price. So we need to be careful with this, because once again, the cost of accessing information is accessible information is going to be in the hands of users and not in the hands of companies. So perhaps 15 years down the road, when everybody has a smartphone, or 20 years from now, when the elderly people who are not familiar with technology have passed away, then everybody would have a smartphone. Right now, it is a very good idea. Nevertheless, we should come up with formulas so that movie theaters or places where they play this audiovisual culture have available equipment that they can lend to those students if they don't have a smartphone or if they don't know how to use it. Otherwise, we would be creating technological exclusion. That's quite clear. Thank you very much for your question. I'm going to try to answer to the first part of your question, which was a technical question. It is true that exposure time is quite short, and it doesn't enable us to delve deeper into the full details. I'm very happy that you asked this question, because you understood our explanation. When you download for free this application, the very system will offer you access to a library, which is like a gallery of contents which already exists and that has been uploaded by ENG. When you find the movie, you need to download the audio description previously. You're planning on going to the movies this evening, so you download the audio description prior to going to the movie theater, depending on the number of bubbles that it'll take up 10 megas or however megas. So once you download the adaptation of the audio description, you will have that audio description available in your smartphone. Now you can start playing the movie at your home or at the movie theater or whatever. So there comes the moment when the mobile tracks 5 seconds of the audio file, and this is what we send to the server that hosts the full footprint for that movie. So it makes the comparison and it sends the information back to the mobile phone. Did I answer your technical question? Yes, you did. Thank you. Now about the second part, The second part has to do with pricing policies, and the ENG representative is going to answer this question for you. Indeed. You're right. This is not the ideal solution. No solution is ideal. Hopefully, I wish we had the perfect solution. But in principle, the application is going to be for free, and contents are going to be free too. We found another source for financing so that we can pay for the work, because the work has been carried out, and it's a very positive piece of work, and of course it needs to be paid for. But as I said earlier, the starting idea was to not charge an extra cost to the users. But obviously, there are always downsides to everything. The situation was the following. Either I stick to the constraints posed by having only 5 or 6 movie theaters across Spain that have audio description, or I create a system so that the user needs to contribute with their investment in a smartphone and in a piece of technology. But this opens up the range of possibilities. It enables me to use this at any movie theater in any city. So up to now, the premises of the movie theater did not really enable to enjoy the service, and of course movie theaters and production companies were not willing to undertake the cost of extending this to more movie theaters. So the alternative was to select another track, which is not exclusive, of course. This is just an alternative that widens the horizon for audio description. And thank you very much. We are going to hear the last question now. And as you know, you can come tomorrow to watch the demo. I wanted to know about the gaming app. Is it already in the market, and the real cost of the product is already in the market? And about the configuration, is that very complex to set up? The gaming application is not yet in the market. We are already in the user testing phase. The product exists as a prototype. It's already functional, but right now we are undertaking the user test. We hope that it will reach the market soon enough, because the positive outcomes justify this, and changes are going to be minimal. But I can reply to you from the technical point of view, but perhaps Nair, who is sitting in the second row, can tell you more about when it will be launched. That's on the one hand. And on the other hand, from the app point of view, the pseudocode used is very simple. Right now, we are optimizing the interface so that fathers, friends, and whoever can configure the app, and according to their capacities, they will be able to have it running. In the worst of cases, someone will need to help them out to configure this. So we need to work towards optimization so we can reach everyone. If someone doesn't have a disability, they can also use the product to do many things, and perhaps that's also the attractive side. Gamers may want to play Mario Kart with another type of joystick instead of with the steering wheel or with the remote. So if those people are encouraged to use things like this, because it'll be a great success in terms of reducing cost for products aimed at people with disabilities. There's another question. This is the very last question, and we need a very quick reply.
Hola, es que se me ha ocurrido la aplicación.
I just came up with a comment. This application that you were mentioning will always be offered to people who are members of ENG, and I'm talking about rights issues, because you put together the databases and you probably took care of different rights. Are there any or is there any sort of restriction in terms of access? Just quickly. this is not really concluded, this topic. We are thinking about limiting access to members only, access that will be obtained through a user and a password, a username and a password, and I would only have access to movies that the ONCE has prepared and that ONCE has paid for its rights also. Thank you very much. We exceeded the time allocated for the session by 7 minutes. I apologize to the people in the next session. Thank you very much.